So you're a fan of Dr. Jack Kruse and Nathan Waltz, and they have taught you the damaging effects of blue light, and now you'd like to possibly take your glasses and put a blue light blocking coating over the top of them. If you don't need prescription lenses, then you can just go to Amazon and buy Uvex, UVEX wraparound glasses, and they will block out a lot of the blue light. But if you have prescription lenses like I do, now you're forced to try to find a company that will provide you with your prescription and coat it with a blue light coating, and so far what I've found is very expensive. So we came up with an alternative thanks to Jason Lauritzen. I found this on his website, but there wasn't a YouTube video, so I decided to put together a short video on how to coat your glasses, prescription glasses, with a blue tinted or a blue dye blocker. And here's an example of a pair that I dyed a couple of days ago. So I'm going to show you step by step exactly how I did it. This is a dye, BPI Super Concentrate Diamond Dye 500 to 550. You'll need a bottle of this, and this is 4 ounces. You're going to dilute that 10 parts water to 1 part concentrate. And the second thing you're going to need to order is a lens holder that looks like this. And that BPI also has that. I ordered the dye and the lens holders from a company called BPI out of Miami, Florida. Here's their website. It's callbpi.com, CALLBPI.com. And their phone number is 305-264-4465. So you'll need to order the Diamond Dye 500/550 and also the lens holder from this company. Here are the 2 items that you'll want to order from BPI. One is a 3-point lens holder, and you can see the model number 9603, costs $24.10. The second one is BPI Diamond Dye 500/550, 4-ounce bottle. Their model number is 37604. Price is $30.70. Unfortunately, they charge you $25.92 for shipping, so the total is $80.72. But with that, you can dye many pairs of glasses. The first thing you want to do is to take a small screwdriver and loosen the screws that hold the lens in place, and then they'll just pop out. At that point, set the frame aside. You have 2 lenses, and then I cleaned them in soap and water. I'm not sure if you need to do that or not, but these are a brand new pair of glasses, but I'd recommend that you do clean them, rinse them very thoroughly. And from what I understand, this dyeing method only works on the CR39 plastic. You can get those CR39 plastic lenses, prescription lenses, from America's Best Optical. In fact, I think it's nationwide, 2 pairs for $69. So you have to make sure you get it completely uncoated and ask for the CR39 plastic lenses. So now that we have the lenses cleaned, what we're going to do is put them into the 3-point lens holder carefully. Set them in there as best you can. Just slide that down and do that. Touch the lens only on the edges like that, and then push that down, and then you're ready to immerse it into the dye. Okay, so next what we're doing is we're putting the diluted solution of BPI dye, and we have 10 parts water to 1 part BPI dye. I put it into a stainless steel container, but according to Jason Lauritzen, he just used a tin can, and I think that would work just fine. Then you're going to want to use your thermometer and measure the temperature. These digital thermometers are very inexpensive at Harbor Freight, so our temperature is 154. We're going to get that up to about 180 degrees. So when you feel that your glasses are dyed enough, and you can tell that by just pulling them out and looking at the color of them, maybe 15 minutes or so, then what I was taught to do is basically take that and immerse it into cold water and leave it there for at least 5 minutes to let them cool down. So now that we have the lenses cleaned, they're ready to be installed back into the frames. And as you can see, this is a pair that we just dyed. This is one that I dyed a few days ago. I did not leave these in the dyeing solution as long, so they're not quite as dark. So here we have the finished product. These are glasses that we just dyed, and these are ones that were previously dyed. These actually will block more blue light than these will. Now, you're going to say to yourself, well, how do I know if they're blocking blue light or not? The simplest thing to do is to simply look at the color blue. And if it turns to a gray, then you know you've got pretty good blockage and you're not letting the blue through. If you're still seeing blue, then you're only partially filtering it out. So hope this has been helpful. I am certainly no expert at it. I learned from another website, but there was no YouTube video, so I decided to put one together. So remember, you have to use a CR39 plastic. You can experiment with other ones, but I certainly wouldn't do it on expensive glasses. You can buy 2 pairs of these glasses at America's Best for $69, so make sure they're completely uncoated. So that's the best way to go that I've found. Thank you. So if you want to get the details on why blue light is damaging to your eyes, I'd suggest you go to YouTube and search out Nathan Waltz and Jack Kruse and take a look at their videos. Jack is very technical. Nathan is more of the Reader's Digest version of it and a lot easier to understand. But between the two of them, they've come up with some extremely valuable information on eye health and human health in general. So you'll want to do some research on this and listen to these guys. Thank you.